My name is Timothy Cipullo. I am a Foreign Service Officer at the U.S. Embassy in Tokyo. This is my second tour in Japan. I was here about 10 years ago, working also in the economic section, covering environment and energy issues. And of course, that was the time when the earthquake and tsunami and nuclear accident in Fukushima happened. So was very busy. It was a very memorable time. So I think first time we had that, second time I came here, we had COVID. I'm afraid if I come to Japan, what will be next? But personally, it is wonderful to be back in Japan. I have spent a total of about 11 years in the country. First came when I was a student at ICU, Kokusai Kidisukyo Daigaku, and have been coming here to work and study off and on since the early 1990s. So this time in the embassy, I'm in the Environment, Science, Technology, and Health unit in the economic section. I'm the deputy there. And I cover, or I specialize in 5G, cybersecurity, and space. So today I'm going to talk about a topic that we spend a lot of time on at the embassy and with our Japanese counterparts, and that is 5G. So I'll go ahead and launch right into the presentation so we can have plenty of time for questions and answers. And also, because I studied at ICU, 日本語はペラペラではないけど、ちゃんぽんはバッチリです。My ちゃんぽん is fluent. So if you want to ask in questions in English or Japanese or ちゃんぽん、どちらでもいいです。So let's go ahead and dive right into the presentation. Could we get the first slide up, please? Great. There we go. I guess slide number 2. Thank you. So what I hope to cover today with you is answer the question, what is 5G? We've all heard about it. We've probably heard different definitions of what is 5G. More importantly, why does it matter? Why should we care what 5G is? Then who are the players? Who's involved in 5G? And then bringing it back to the topic of diplomacy, what are governments, and specifically what is the United States government doing in 5G? And I'll also cover what the government of Japan is doing in 5G. Next slide, please. So I would like to, before we jump in, I would like to start with a 5-minute video that is a basic explainer of what 5G is. And I think that'll give you a little bit of background, and then I will go into a little bit more depth as we talk.
Thank you very much, Tim-san. I'm going to start the video. This is a quick message for the interpreters. I'm going to use the automatic Japanese captioning, so please don't feel the need to interpret the video.
.5G is the 5th generation of wireless data networks, and it will improve them far more than 4G or 3G ever could. You'll feel it in your phone, your home, your car, and in the city and town around you. Downloads and streaming should happen literally without delay. Cars will talk to each other to prevent collisions. And untethered augmented and virtual reality can finally be achieved with real-time response. Not to mention industrial benefits like remote surgery or drone control. 5G does its magic with 3 key abilities. First, high bandwidth. 4G could only muster about 200 megabits per second of data throughput on a good day. 5G can handle up to 1 gigabit or more. That's 1,000 megabits a second on up. Low latency. 4G suffers from around 100 milliseconds or so in response delay or latency. 5G reaction time can be as low as 1 millisecond, which makes everything happen virtually instantly. and dense connections. In a given square kilometer, 4G could only manage to connect about 1/10 the amount of devices as 5G can. If that's some of what 5G does, how does it do it? 5G uses new radio technology, the part of any wireless device that makes the connection. 5G uses some radio frequencies in a band known as sub-6, from 600 megahertz to 6 gigahertz, part of which is also used by current 4G LTE. But 5G will also use a higher band of radio frequencies, from 24 gigahertz to as high as 86. These much higher frequencies bring with them much higher data rates. Now, while these new 5G radio waves can carry more data with higher performance, they can't carry it as far. So 5G will use a lot of so-called small cells. These are small versions of the big cellular towers we all know. 5G will also use some new tricks in these small cells, like beamforming, to efficiently aim transmissions rather than just spray everything everywhere. The bottom line, though, you will need new phones, tablets, portable hotspots, and the like, with a 5G radio inside to connect to the new 5G networks. Your current 4G or even 3G gear can't tap into it. 5G networks will also position more data and computing resources closer to you that will avoid blunting 5G's low latency benefits. Most of us do think of phones when we think of wireless networks, but phones may actually be the least interesting thing about 5G. It will also power autonomous cars, so they have awareness of every other car, bike, pedestrian, and traffic signal around them. Smart cities based on 5G can make almost anything that's electric also connected and aware. When a bridge needs repair, why can't it tell someone? With a mesh of 5G connected sensors, it could. And then there's your home. 5G will offer a new way to get internet there, eschewing cable or DSL, and one day maybe even obviating your Wi-Fi router altogether, as devices may just use 5G natively to connect directly to a wireless ISP. 5G has renewed concerns about the safety of cellular radio waves. Some cities have taken action to block 5G deployment. Health questions come up around 5G's use of microwave frequencies, lots of them as we've seen, thanks to that large number of small cells that will be installed around us. Now, while 5G may sound like a lot of microwave ovens mounted on poles running with their doors open, in fact, microwaves are nothing new. Already emitted by your current smartphone, old cordless phones, your wireless headphones and earbuds, and just about anything with Wi-Fi, as well as, yes, microwave ovens. But even 5G's highest frequencies are considered by scientists to be non-ionizing radiation. You have to move on up to X-rays, gamma rays, and cosmic radiation to find the kind of emissions that will harm cells, and 5G is far below that. 5G follows the inverse square law, losing power rapidly at even a small distance from the small cell. The US CDC says there is no scientific evidence to provide a definite answer to the question of cellular radio wave safety, whether it's 3G, 4G, or 5G. 5G will take years to roll out and some investment on your part, but the complexity of that deployment and debugging should be worth the wait, delivering the world we've been promised for a long time, where everything is connected, aware, and responsive, and a world in which we can stop worrying about the availability or performance of connectivity in the first place.
Thank you for that. If we can go back to the slide deck, we can continue. Thanks. So I'll just, if you can go back up to slide 3, please. Just to recap the main points from the video, there were roughly four generations of cell phones that some of you may be too young to remember the early ones, like on 1G and maybe 2G. 2G in Japan was the beginning of iMode when people started using internet on their mobile phones. 3G, of course, was the era of the iPhone and then later Android. 4G is what we're using today, and 5G is what is being rolled out now, still early in its adoption. Next slide, please. The other Other takeaway from the video is, so what are the advantages that 5G has? What does it do differently? Improved bandwidth to carry more data. Improved capacity lets you put more devices onto the network. And improved latency, meaning the lag between the time data is sent and the time it's received. So these things, the picture on the bottom, the cars, we're saying why do we care about these advances? So if you're downloading a music file or even a video on your phone, having lower latency or higher bandwidth isn't that big a deal. You just wait a few more seconds for the data to arrive. But that's the uses today of 4G. But looking at things that'll depend on 5G, such as automated cars and cars that communicate with each other, if one car in front puts on its brakes and it sends a signal to the car behind it, I'm stopping. If the data gets there in 2,000th of a second, the car behind will be able to stop. If the data takes a second and a half, you could have a collision. And so in these real world cases, think about robots on a factory floor that need to talk to one another and coordinate their movements. That's when the latency, reliability, and capacity become much more important. So another key phrase from the video was phones may be the least interesting aspect of 5G technology. And that's what I really want to get into, the why it matters. It's not for having a faster connection on your phone, although that's certainly nice, but it's for these new technologies that it will enable and technologies that we have not yet thought about that it will enable. So if you could go to the next slide, please. Another feature that wasn't covered in the video, but that's very important to both individuals and governments, is the improved security of 5G. 5G has various design features designed to make it more secure, but this depends very much on how it's implemented. And this is why governments are so interested. The capacity of 5G will allow new infrastructure to be built on top of it. And if you have, for example, automated cars or drone networks or smart buildings that are relying on this, you need to know that the structure underneath them that's powering them is secure. And that is why governments are so interested these days in supply chain. That is the question really of where does your equipment come from and how do you know that the equipment that you're putting into your network is secure? Let's see, go to the next slide, please. Another very direct reason why governments are interested in this is because economically it's huge for national competitiveness. This is an estimate of what telecom companies around the world are going to spend rolling out 5G over the next 4 years. And it's estimated at $500 billion worldwide. So obviously, if you're an equipment maker, whether it's NEC or Fujitsu or Intel or Cisco, you want to capture a piece of that market. That is serious money and serious jobs for the countries that are going to build the equipment that 5G runs on. It's particularly of interest to the government in Japan. Japan, to be very honest, kind of missed the boat on 4G networks. Back in the earlier days, the 2G networks, there were a lot of dominant Japanese companies. In the Docomo iMode days, the country was really a pioneer in the mobile network. And unfortunately, these days, Japan plays a much smaller role in 4G. When you think about handsets, the leading handset makers in the world, I don't think there's a Japanese company even in the top 10. And so this was sort of a missed opportunity in Japan. And the Japanese government wants to get back into the race with 5G and later 6G technology. The other reason this matters for competitiveness is artificial intelligence. There'll be so much information flowing over 5G networks, and companies and governments are going to use that information to train artificial intelligence algorithms. And so having access to that data allows you to develop better artificial intelligence and machine learning. And so the countries that develop this technology will also get a boost in their AI efforts. Let's see, can we go to the next slide, please? So this one is, I had alluded to this earlier when I said that phones are the least interesting part of this. A way to look at 5G really is, this is bringing a new level of infrastructure to the masses, to billions of people around the world. And what that means is things are going to be built on top of this, some of which we don't even think about. So here's an example. Some of these I took these from the United States actually, but when postal service became universal in the United States, everyone got mail delivered. That led to the mail catalog order business like Sears Roebuck, LL Bean, and so on. And there was an entire industry built on this service that was provided, in this case, mail. The second one being home appliances. Once houses were wired for electricity, it created a new market for washing machines, dryers, irons, vacuum cleaners, etc. To say nothing of televisions and Famicom and all the other entertainment that relies on the electrical network. And then third example is advertising. When television became widespread, it spawned this whole industry of television advertising. So you've got trillion-dollar industries that are reliant upon this technology that couldn't exist without billions of people having access to this technology. And 5G will be no different. We've talked about some of the possible applications like remote medicine, automated driving cars, automated factories, and so on. But it's almost certain to say that somebody is going to come along and invent some application that runs on 5G that nobody has thought about, and it's going to turn into the next Rakuten or Amazon or Facebook or whatever. If you go to the next slide, please. More recent examples, when people got internet in their home and it became widespread, as I said, then online shopping became a thing. This replaced the mail order catalogs, and now you have Rakuten and Amazon and all the others. Likewise, when people got smartphones in their pocket, that enabled applications like Uber and Grab Taxi, and later on Uber Eats, that couldn't have existed until this became widespread. And the last one, for better or worse, social media is another offshoot of everyone having a camera in their pockets, now able to post selfies and photos of their food from anywhere on the world. Next slide, please. So moving on to who are the players. Up until about 2 years ago, the 5G industry was dominated by 3 global players: Nokia, Ericsson, and Huawei. These are the large equipment providers. I think together they supplied about 90% of the 4G market, and they were early adopters in 5G. There are some smaller players. I think ZTE, Samsung are also in this market. But the one thing these have in common is these are all closed systems. And what that means is if you are KDDI or SoftBank or Docomo, you would get one of these companies to build your network, and then you're locked in. So if you get an Ericsson network, when it comes time to upgrade or to repair, you need to go to Ericsson to get the equipment to replace that, because Ericsson is the only one who knows how their equipment works, and the user doesn't have any knowledge of what's going on inside the hardware. This is a situation that the telecoms really don't like, because obviously once they choose a partner, then they're locked in. The huge change in 5G has happened in the last 2 years. Next slide, please. And 1 second, let me just get my slides back up. There we go. This is a development called Open RAN, or Open Radio Access Network. In simple terms, this could be a whole other hour presentation, but in simple terms, Open RAN is a way to use software to recreate the hardware that sits in a network. So for example, if you were building a network, you need cell phone sites. And these are the base stations, the thing that's attached to a telephone pole with an antenna on it, and that talks to your phone. It used to be that you would buy a Huawei or an Ericsson or a Nokia base station, but now some very clever engineers have figured out a way to take generic off-the-shelf hardware. So you could buy a Fujitsu server or a Dell server or compact server and run software on it that recreates the functions of this specialized network hardware. And when you do that, it opens up your choices. Now you can buy your equipment from hundreds of vendors, and you can mix and match, because all the different equipment talks to each other with software standards. So the base station talks to what's called a distributed unit, and that is a kind of a traffic cop that takes data from the base stations and sends it back to the internet. With the invention of Open RAN, that means that all these companies you see on this slide are playing a role in developing 5G equipment. And so the companies that build the networks love this, because now they can go to hundreds of vendors, and that has some real advantages in terms of cost. It costs about half as much to build a network with Open RAN. And in innovation, when you have all these companies competing, the pace of new ideas and improvements to the network is much faster than when you only have 3 companies that are working it. One of the leaders in the world on Open RAN is Rakuten. Rakuten they decided in 2018 to become the 4th telecommunications provider in Japan. And they approached this with a brand new model entirely based on Open RAN. And they worked with all these partners and developed their own system of hardware and software to build out the network that is now, it's called virtualized, meaning it runs on generic hardware. And that means that they could build it at half the cost of Docomo or SoftBank, which is why their prices are lower. And they can also upgrade it much more quickly. In the same way that you get an upgrade push to your cell phone to update the software, that's what they can do with their 5G network. So the other thing that is interesting from our perspective is the Rakuten network is entirely built in Japan, and it's sourced from hardware from Japan, the United States, and South Korea, which answers that supply chain problem. Do you trust the suppliers of the hardware that you're putting your infrastructure on? I've just got a couple slides to go before we get to question and answer. Let's move on to the next one. So who are the players is the other question. There are standard setting groups. So Open RAN requires standards so that if you buy an NEC server, it can talk to a Cisco router and it can talk to Fujitsu switch and so on. In the same way that when you have a laptop and you want to connect to Wi-Fi, it doesn't matter what brand your Wi-Fi router is. It could be a Buffalo, it could be an NEC, it could be any brand, but because it complies to the Wi-Fi standard, you know that it's going to work with your laptop. So the groups that set these standards are the 3GPP, the ITU, International Telecommunications Union, and the ORAN Alliance, among others. And they continue to refine these standards so that any company, large or small, if they build equipment according to these standards, it should work with the other equipment. We see this as a very positive way forward, because by opening up the system, you invite new innovation. You've got new companies that can compete, and it drives down costs, which mean that that 5G is going to be adopted more quickly around the world. And then last slide, looking at the role of governments in this. The reason I spend many hours a day working on this is because for each country, it's important to have control over your own infrastructure. If you're going to be putting your nuclear power stations on a 5G network, you need to know that you trust that network. And that's why it's important that you have standards for security, that security is built in from the start, and that you're able to that there's transparency so you can see when there are problems on the network and fix them. Also, to remain competitive in the 5G and later 6G race, as well as for AI, as I mentioned. And also to speed up the deployment of 5G, which is going to enable all these follow-on businesses that will be built on top of it, that are going to create jobs and economic prosperity in the countries that utilize them. So that's it for my presentation. I'll wrap up there, and I am happy to take questions in any language.